All right, well, welcome back to my channel. So today I want to talk about comparing the SLS4ALL MK1 Inova, which I'll just refer to the Inova going forward, with an entry called Loopzizo K-100. So just to remind you all, I purchased the SLS4ALL MK1 Inova in the fall of 2024. It shipped and received it in November that same year, got it assembled by February of 2025, and I was printing parts by early March. And then since then, I've published a video that compared it to the two key compact SLS printers, the Formlabs Fuse 1 Plus and the Centret Lisa X. And you can find that video here that basically says, was the SLS4ALL worth it? And I compare it to the others. Now, a couple months ago, I saw an advertisement for a desktop SLS 3D printer that was going to launch on Kickstarter in January of 2026. Now, it was called the Loopzizo K-100, and it made claims of being the industry-leading build volume, had industrial precision, modular architecture, and a 27-minute rapid printing. Now, it was advertised at a super early bird Kickstarter price of almost $5,200. And that was a 35% discount off their suggested retail price of approximately $8,000. Now, as an owner of the SLS4ALL Inova printer, which I fully assembled the full kit, I thought it made sense to compare the two and see which one appeared to be the better value. Now, I also thought I would address some of their claims. The only videos out there on the K100 are Loopzizo published, and then there's one by the Sammy Liu Tech, who I've seen review other Chinese-made products, but it seems obvious he's getting paid for his reviews, and he just repeats the marketing literature that Loopzizo has already released. So an independent review of the actual machine would be nice for those of you wanting actual user data, but I suspect that Loopzizo will use the Kickstarter as their feedback system. So who is Loopzizo? So based on some online searches, Loopzizo is a relatively new Chinese brand under the parent company Loopzizo Intelligent Technology, and it was established in 2024. Now, I thought it interesting that the company states that breaking foreign price monopolies in the 3D printing industry is a foundation of its business. Some people familiar with the Chinese business model could interpret that as undercutting the market with subsidized copycat product. Now, that's not what I'm saying here, but it's a common practice to Chinese to come in and find a big brand that dominates and try to insert a product that is similar. Now, a quick look at their website shows 3 models of SLS printers, but it doesn't appear any of their products are in production yet. Now, the Kickstarter K100 shows mass production in March and shipping by May of this year. Now, they also show a powder recovery station available at an additional cost of $1,300. And as of the time of this video, they had 83 backers and have raised over $400,000 towards their Kickstarter. So first, let's look at the overall spec comparison chart shown here. So the first item is the build volume. Now keep in mind that I only count the actual dimensions that can be used for printing. And as you can see here, the Loopzizo overall build volume, and this is specifically for PA12, the volume is over 50% less than the Inova. And the size of parts you can make on this will be smaller. Now, their claim of industry-leading build volume is false, as the Inova is over 2 times larger, and both the Fuse 1 Plus and Centret compact models are also much larger. Now, the layer thickness of most SLS compact models is about 0.1 millimeters, with the more expensive models capable of about 0.06. Now, the K100 seems to meet the standard here with its 0.1 millimeter. It also states its accuracy as plus or minus 0.1 millimeter. Now, most industrial SLS 3D printers are typically around plus or minus 0.3% or plus or minus 0.3 millimeter, whichever is larger. And that's for standard PA12. For the Inova, I consistently get plus or minus 0.3 millimeter. If the K100 can achieve what it says, it would have better accuracy than industrial models. However, because they are using a 5-watt laser, it can be much better at finer details, but it would lag behind in other areas. Which actually brings me to the next 2 features, laser type and build speed, which often go hand in hand. Now Loopzizo, they're using a 5-watt diode laser, and the Inova has a 10-watt diode laser. Now a 10-watt laser processes layers much faster, and it should reduce build times. Now Loopzizo claims a 10 millimeters per hour print speed in the z-axis with no reference to nesting density. Now I've been able to achieve a 10 to 11 millimeter per hour speed with 25% nesting density on the Inova. Now reporting print speed with nesting density is important to get a good apples to apples comparison. Obviously, with a lower density of parts in your build volume, it will positively influence the time the laser is sintering between layers. Now, as a point of reference, the Micronics desktop SLS on Kickstarter, it used a 5-watt laser, and it stated a print speed of 8 millimeters per hour at 15% nesting density. So a lot lower density and lower print speed. So I believe the Loopzizo build speed is misleading until it references a nesting density used for the build speeds. Now they also make another claim on their Kickstarter page that they have fast turnaround at 27 minutes from model to part. Now this is very misleading because if their build speed is 10 millimeter per hour, this means they could do a 5 millimeter thick part in about 30 minutes. And that's a very, very small part to make a claim on turnaround time. And not even sure if this is counting the heating time. Now, as for powder types, it claims it can do PA12 and TPU out of the box, but it also shows PA11 on their spec sheet. Now, I've only used PA12 on my Inova, but other users have successfully printed TPU as well as glass-filled PA12. Because the Inova is open source, all the parameters are adjustable to optimize for any other types of powder. The Loopzizo also says its parameters are open. Now the Loopzizo appears to have a blade type recoder. In my previous video comparing the Inova recoder blade to the Fuse 1 Plus and Syntera Laser X recoder rollers, I think both blades and rollers have advantages and some disadvantages, but overall I think the recoder blade on the Inova has been very effective as it rides on a trolley on slides. And after a year of printing with powder dust in the chambers, I've just recently cleaned the rails and trolley to ensure smooth recoating. It's not clear how the recoder blade on the Loopzizo is mounted or how it is driven, but online searching seems to indicate it uses a system very similarly used on the Syntera Laser X. The Inova boasts a 7-inch touchscreen control, but they also have a desktop app that allows you to perform all the same functions on your computer as well as monitor the print remotely. And so obviously that's as big as your screen that you have for your laptop or computer. Now, you can also transfer print jobs from the desktop to the print wirelessly or through an Ethernet connection as well as through USB. The Loopzizo screen looks more like a 3 to 5 inch touchscreen from the videos, and their spec sheet only shows connectivity through SD cards or USB, but online searching says it has wireless and Ethernet to upload your files. Another claim that Loopzizo makes is that it has a 15-minute heat time, but it doesn't distinguish if that's for both the 220 and the 110 volt system. Now, preheat of SLS chambers is critical before the print starts as it prepares the powder bed to just below the material's melting point, which minimizes thermal stress, prevents warping and distortion, and it ensures consistent mechanical properties. And it allows the laser to sinter efficiently, leading to dimensionally accurate and stable parts. Skipping or rushing preheating leads to poor part quality, potential warping, and thermal issues. Now the Inova needs 40 to 45 minutes of preheat for their 220 volt system, and I have consistent results preheating for 55 minutes on the 110 volt system. Even the Formlabs Fuse Plus and the Syntera Laser X compact systems require at least 1 hour of preheat. So a 15-minute preheat claim could be misleading. However, it is a smaller system overall, so it may not need the same length of time to get good heat saturation, but 15 minutes seems pretty low. Now dimensionally, the overall Loopzizo unit is about 4 inches shorter than the Inova, and it's about 10 inches less wide. But this side obviously impacts its build volume and size of the parts you can do, so the trade-off depends on the size of parts you need. Now Loopzizo does boast a modular design, very similar to the Formlabs Fuse Plus, and where the build chambers can be inserted, removed out of the main chamber to move to the process station. And this is one advantage it would have over the Inova. In addition, the power module, laser assembly, and motor units can all be accessed and serviced independently for easier maintenance, and that gives it a leg up on the Inova as well. So which unit gives more value for the money? Well, short term, at a Kickstarter price of $5,200, the Loopzizo appears to be a decent value. But there are still too many unknowns about this new Chinese company making some unproven bold claims on print speed and heat up times for an SLS machine that has a significantly smaller build volume than other industry players. At their $8,000 retail price, I'm not sure the trade-offs in build volume and print speed with a 5-watt laser makes this a good choice, considering it's a startup Chinese company whose quality is unknown and their support could be lacking. The better value, and I'm being biased here, would be the SLS4ALL Inova kit, which now sells for $74.90 US dollars. But it does require you to assemble the unit yourself, which could be a deterrent for many. However, there is a complete volume of YouTube build videos by me from start to finish, and the founders of SLS4ALL have consistently shown the commitment to support everyone with any issues, as well as creating new features and software updates to make this machine overall a better value.